second side of this worksheet, we're going to use the explicit formula every time. There it is. So what if a sub n is unknown? How do you find a sub n? Plug on all the others in your calculator and hit enter. That's easy. Okay. What if a sub 1 is unknown? For instance, let's say I had 10 equals a sub 1 times 1.2 to the 6th. How do I solve for a sub 1? I divide this by 1.2 to the 6th. That's easy. Okay? What if r is unknown? So let's say I had 32 equals 2 times r to the 10th. How would I solve that? Divide by 2, r to the 10th, and I take the 10th root. Does anybody not know where the 10th root button is? Well, then let's say it was a little harder than that. 14.6 divide 2. So if I did 14.6 divided by 2, I get some decimal. Then I want to do 10 math number 5. And then I don't want to type this in, I just do second answer. So that would be my r value. What if my n minus 1 value is unknown? We don't know, so our best option is guess and check if you want. I wouldn't. You graph it and use the table. Okay? If you look down at the bottom, I just want to make sure everybody understands how this problem works. If you were, I need to edit that, if you were to place 1 grain of rice on a square of a chessboard, 2 grains on the next square, 4 grains on the third, and so on, how many grains would there be on each of the following squares? So if we were to fill this up, 1 grain of rice, 2 grains of rice, 4, 8, 16, and you go all the way until the board is full, then what would my equation for a sub n look like? 1 times 2 to the n minus 1. Okay? Now, the final question asks you, how many grains of rice are there in total? Remember when we were doing arithmetic sequences and we had that trapezoid picture of a movie theater? 48 seats on the back row, 2 on the front. We found a really easy way to add all those up. You just take the average of the first and the last row, and then you times it by the number of rows, and that was it. Well, there's not an easy way to show the formula for the sum of a geometric sequence. There is a way to show you what it is, and I might show it to you, but it's a lot more confusing. So I've given it to you. So if you look down here, that is the formula. The S, which stands for sum. The sum is you take a sub 1, you take your a sub 1 value, and you multiply it by 1 minus r to the n over 1 minus r. And make sure when you plug that in your calculator, you have parentheses around those. And that will tell you how many grains of rice there are in total. So, for your final question, because you guys are so smart, when you get this number, and it's huge, it's something times 10 to a big number, okay? I want to know, is that enough rice to feed the world? Well, I will give you some numbers. Here's what you're going to use. In 1 pound of rice, there are 29,000 grains. Well, instead of looking at people individually, we're going to look at how much the world currently consumes every year. Total. Not individually, total. So, the current world consumption of rice is 475 million tons. Now, granted, we eat a a lot of other things than rice, especially in this country. But this is the current demand for rice. So what I want to know as your final question is, how many times will the chessboard fulfill this need? Okay. So obviously, this is in grains per pound. You're going to need to convert that somehow, and you're going to need to use this number, and then that somehow it needs to affect that number. And I'll give you a hint, it's more than one. It's it's amazingly big. They fit it all in that little square. Just to give you a hint, Tom and I also calculated this using pennies. If you were to put 1 penny, 2 penny, 4 pennies, and then how high would all of the pennies reach stacked on top of each other? And we thought, well, let's see if it would make it to the moon. Oh boy, way further than that. So we're like, okay, let's try to make it to the sun. No, way bigger than that. So what we did was we found the distance from the sun to Pluto. Those pennies would reach from the sun to Pluto 4,800 times. Yeah, that's a lot of pennies. Yeah, that same problem. Well, but you don't really understand how far that is, right? You can't internalize the distance of a light year. Yeah. So, what? Just normal stacked, not on its edge, on its face, just like normally. Yeah. We found the thickness of a penny in millimeters, and then we converted that into how many pennies there are in a kilometer, and then we took the kilometers from Sun to Pluto, and we divided it out, and it was almost 5,000 times. So we decided to go with rice instead. Because you don't, I mean, you can't imagine how big that is. It's hard for you to even imagine how far it is to Pluto, but how many times can you feed the world? It's not as many as 4,800, but it's more than one, and less than 4,800. Okay, I'll leave these numbers up on the board and the equation. Get rid of this. Good luck.